We're on SAT Practice Test 8, Math Section 1, Question 14. What's the level of difficulty here? It's hard. It's the first hard question, kind of medium hard. Each year, the value of an investment increases by 0.49% of its value the previous year. Which of the following functions best models how the value of the investment changes over time? This question is so easy that it's hard. First thing you want to do on a question like this is write down A, B, C, D, and let's just ballpark. ETS tells us that the investment increases in value. So is it going to decrease or is it going to increase? The facts of the question say it's going to increase. So A and B are obviously gone. Now the question is it going to increase exponentially or is it going to increase linearly? The easiest way to do this is just to try it out. Is there anything special about 0.49% as a percentage that goes up? And there's not, other than the fact that it's obviously a crappy investment because it's not going up very much. It's not special that it's below 1%. It's going to operate like any percent. So let's just see what would happen with a percent that's easier. Like, how about 50%? And then how much money is invested here? ETS doesn't say, so let's just make something up. Let's make up year 0. We go to the bank and we invest $100. So at year 1, what happens here? It's $150. Okay, year 2 is going to be 50% of 150. So I'm just going to cross off zeros here. You could also do this on your calculator. That's $75. What's going to happen in that $75? You're going to add it to 150. Again, don't be ashamed to use your calculator here, and you're going to get $225. So year 0, you had $100. Year 1, you had $150. And now year 2, you got $225. Is this an exponential increase or is it linear? Linear means goes up exactly the same and exactly the same way each time. Is that what's happening here? It's not. So the answer is C. You get this right real quick and move on. We're on SAT Practice Test 8, Math Section 1, Question 15. What's the level of difficulty here? Hard. Guys, this problem is proof that Evil Testing Service hates you. A circle in the XY plane has a diameter within points 2, 4, and 214. An equation of this circle is this giant mess where r is a positive constant. What's the value of r? Alright, this is the circle formula. It's not in the SAT formulas box. You do not need it for this problem. You only need to know that r is the radius. Just draw this thing out, man. Here's the XY plane. I'm going to put 2 over on x because 2, 2. And then I'm going to go up by 2's. 2, 4, 6, 8, 10, 12, 14. So the first point is 2, 4. So that's 2, 4. So it goes right here. And the second point I know is 2, 14. So that's 2 and then 2, 4, 6, 8, 10, 12, 14. I'll label these points. These are the endpoints of the diameter of the circle. If you want, you can draw the circle in here. It doesn't have to be to scale or anything like that. This is the diameter of the circle. That's what ETS tells you. Okay, well, let's just think, what do you think the radius is? This is the center of the circle. It goes from 14 up here to 4 down here. You could also count 2, 2, 4, 4. This is going to be in the middle here. Guys, this radius is going to be 5. And that's it. That's the answer to this question. You get it right, and you move on. We're on SAT Practice Test 8, Math Section 1, Question 16. What's the level of difficulty here? It's hard. But it's only hard because most people freak out when they see trigonometry on the SAT. Don't do that. You don't need to know any trigonometry to get this problem right. In right triangle RST, the sum of the measures of angle R and angle S is 90 degrees. The value of sine r is root 15 over 4. What's the value of cosine s? All right, where is this figure? It's not here, so you got to draw it. It's a right triangle. Triangle RST measures of angle R and angle S. When you add them up is 90 degrees. So what do you think T is? T's got to be 90. Doesn't matter where you put R and S. Sine R is root 15 over 4. You're looking for cosine S. So write that down and circle it. All you need virtually every time to get any trig problem right on the SAT is SOHCAHTOA. Sine, cosine, tangent. The sine of r is root 15 over 4. It means that the opposite over the hypotenuse is root 15 over 4. So this is opposite over hypotenuse. Talking about the sides here, the opposite side of angle r. What do you think that is? It's across from it, root 15. Hypotenuse, you know this one. It's right here. So this is 4. Cosine is adjacent over hypotenuse. All right, adjacent means next to. There's two sides adjacent to angle S. One of them is the hypotenuse, though, so that's not the one that's adjacent. It's this one. So it's root 15 over the hypotenuse, which is 4. Guess what? That's it. That's the answer. It's B. You get it right, it's easy. You move on. We're on SAT Practice Test 8, Math Section 1, Question 17. What's the level of difficulty here? It's definitely hard, but not if you plug in. How do you know this problem is a plug-in? There's a bunch of letters here. There's a bunch of letters here. There's a bunch of letters in the answer choices. There's no constants. It says in terms of something. It says in terms of P and K. These are all indicators that you can plug in. And if you plug in, you turn hard algebra into very easy arithmetic. The given equation relates the distinct positive numbers p, k, and j, which equation correctly expresses 4j plus 9 in terms of p and k. In your mind, I want you to cross off in terms of p and k. It's useless information. You're looking for 4j plus 9. So write it down and circle it. Go up here and make up numbers for letters. You should start plugging in where there's math happening. Is there more math happening at P, K, or J? It's obviously J. So I'm going to make J my favorite J in the whole wide world, my favorite number to plug in, which is 2, which means that 4j plus 9 is 4 times 2 plus 9, which is 17. Incidentally, that's what I'm looking for, so I'm going to go down here, I'm going to write it down, I'm going to circle it big. And then the next place that most math is happening is at K. I got to use something that's divisible by 17. I'm going to use 51. So K is 51. And then P, I don't get to make stuff up anymore. P has to be 51 divided by 17, so P has to be 3. I'm looking for 17. So K over P. K is 51 over P is 3. That checks out, that's 17. I'm golden. If I'm in a hurry, I could just pick it and move on. K times P, that's 51 times 3. I don't know what that is. I don't need to know. It is definitely not 17, so it's gone. K minus P, that's 48, not 17, so it's gone. And then P over K. This is probably the answer for the people who insist on doing algebra. 3 over 51, which is some little fraction. So the answer's got to be A. You are sure you're right when you leave this hard question, when you plug in. Please plug in. It's the easiest way to raise your score. Get it right and move on. We're on SAT Practice Test 8, Math Section 1, Question 18. What's the level of difficulty here? It's hard. Evil Testing Service loves these questions. They come up all the time. I hate them. They're a lot of work. You can and should plug in the answer choices. It's the best way. You'll avoid all the potential wrong answers. It just sucks. You got this equation, y is bigger than 13x minus 18. And all they're asking every time is just which set of numbers in the answer choices works for x and y every time. So write A, B, C, D, and then just go down the answer choices and start plugging in. When you plug in, rewrite the chart. You don't have to write the whole chart, but write the numbers you're plugging in. It will help you to avoid confusing x and y. So here we've got y is 21. That's bigger than 13 times 3, 39, minus 18. Do that on your calculator. 39 minus 18 is 21. So, is 21 bigger than 21? It's not. So A is gone. You don't need to do any more work in A. And now you go to B. Again, write the chart, the parts that you're going to use to avoid mixing up x and y. This time we've got y is 26 is bigger than 13 times 3, you've already done that, 39 minus 18. You already know that that's 21. Is 26 bigger than 21? It is, that checks out. So, got to keep going. The next set of numbers is 5 and 42. So, y is 42. That's bigger than 13 times 5. Calculator math. That's 65. Minus 18. More calculator math. That's 47. Is 42 bigger than 47? It's not. So B is gone, and you move on. C. This time I've got y is 16. That's bigger than 13 times 3, 39, minus 18. You've already done that. 21. Is 16 bigger than 21? It's not. So C is gone. If you're in a hurry, you know D is the right answer, because nothing else works. But let's check it out. This time, what's my y? It's 26 is bigger than, we've done this 18 times now, 39 minus 18. Checks out. All right? 52 is bigger than 13 times 5. We've already done that. That's 65 minus 18. 52 bigger than 47. Checks out. All right? So last one. 91 is y. Is bigger than 13 times 8. This one's new. Calculator math. 104 minus 18. More calculator math. 91 is bigger than 86. So the answer is D. You get this problem right. You know you're right. And now you get to move on to some really hard problems to close out Section 1. We're on SAT Practice Test 8, Math Section 1, Question 19. What's the level of difficulty here? It's hard. How hard? Pretty hard. Keep that in mind. Line L is defined by 3y plus 12x equals 5. Line N is perpendicular to line L in the xy plane, because where else would it be? What's the slope of line N? So write down what you want and circle it. Let's talk about how to get this question wrong. Most people know how to find perpendicular slope. They know that you find the slope, which is attached to x, you flip the fraction, and you change the sign. So most people are going to say, okay, man, hey, that's 12. That's attached to x. I'm going to flip the fraction, and I'm going to change the sign. Guys, this is one-stop math. One-stop math is going to be right on easy SAT questions, but there's no way it's going to be right on hard SAT questions. There must be more going on. What else is going on? Well, the line equation looks like this in SAT land. Does this equation look exactly like this equation? It does not. So we're going to have to manipulate it. The y is in the right place. The x is not. We've got to move it across the equal sign. It's going to change signs. This plus 5 part doesn't really matter. We're looking for the slope. Now, here's how most people are going to get it wrong again, right? They're going to say, oh, I see, so it's negative 12. So I'm going to flip it, and it's going to be positive, and they're going to stop right here. No, y has to be naked and alone. Is y naked and alone? It's not. So you got to make it naked and alone. You got to divide every term by 3. Y equals negative 4x, and we're just looking for slope, so this part doesn't matter. Now, the slope, m, is negative 4. Now, after some steps, we can flip it and change the sign. And here is your answer. Notice that hard questions take some work and they're tricky. Be careful, get it right, move on. We're on SAT Practice Test 8, Math Section 1, Question 20. What's the level of difficulty here? It's hard. You got this big old nasty equation. In the equation, d and g are unique positive constants. When the equation is graphed in the xy plane, how many distinct x-intercepts does the graph have? All right, so you can't write on the test. You've got to redraw this equation. What does x-intercept mean? I always write this down. Do I really write it down? Yes, I do. X-intercept equals y equals 0. And that makes sense, right? Little xy plane here. At the x-intercept, wherever it is, y is going to be 0 because it's on the x line. So y is 0. 2's not going to change. Either this is going to have to be 0, this is going to have to be 0, or this is going to have to be 0, or this is going to have to be 0. Because anytime you get 1 0 in here and you're multiplying, you're going to make everything 0, which is going to make y 0. All right, so x minus d could be 0. That's one thing that could be 0. X plus d could be 0. That's two things that could be 0. X plus g could be 0. That's 3 things that could be 0. X minus d can be 0, but you already did it, and it says unique here, it says distinct here. So how many distinct, unique times can you make a 0 in here to get y equals 0? And the answer is 3. So the answer is B. This problem is not that hard. You can get through it very fast. It's also a problem that comes up very frequently in the SAT. So in some form, you're going to see this. So understand how it works. Get it right and move on. We're on SAT Practice Test 8, Math Section 1, number 21. What's the level of difficulty here? It's hard. For most people, it's going to be stupid hard because they're going to see this term coefficient. They're going to see these exponent terms. They're going to freak out. But guys, this problem is very simple. It's really just a vocabulary problem. And it makes me mad because it's really easy. It's hard to explain. It's actually kind of poorly written. For the exponential function f, the value of f of 1 is k. K is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? What's a coefficient? You've been dealing with coefficients your whole life. It's a fancy term for something very easy. Ever seen 3x? 3 is the coefficient. It's the number that's attached to a letter. You ever seen 4y? 4 is the coefficient. How about 8n? What's the coefficient? It's 8. So it's just like the beginning number. So you're going to do f of 1, which means you're going to follow the directions. So every time you see an x, just means put in a 1. Before we do it, what are the coefficients in these answer choices? What's the coefficient in A? It's 50. In B, it's 80. What is it in C? It's 128. And what is it in D? It's 204.8. So you're going to want to do the function and end up with the coefficient. So again, you're just following directions. Every time you see an x, you're going to put in a 1. So this one is 50 times 1.6 to the what? to the 1 plus 1, which is 2. Okay, you don't need to do anything else here because you know that you're going to try to get to 50. And whatever this is, it's way bigger. Well, it's somewhat bigger than 50. It's not 50. So that's gone. So I'm going to write A, B, C, D up here. Cross out A. All right, B. Do it again. 80 times 1.6 to the what? To the 1, because it says we're supposed to do f of 1. So 80 times 1.6, you're supposed to end up with 80. Is that going to happen? No, you don't need to do anything with that. All right, fine. Let's try C. 128 times 1.6 to the x minus 1, to the 1 minus 1. What's that? 0. All right, this is interesting. There's a rule here that you got to commit to memory and know. Anything to the 0 power is 1. So what is 1.6 to the 0 power? It's 1. So all of this is just 128. So when we did the function, do we end up with the coefficient? We do. So C is the answer. If you want to try D, it's 204.8 times 1.6 to the 1 minus 2, which is negative 1. Some disastrous calculator thing that you have to do. You know you're not going to end up with 204.8. It's gone. The answer is question C, and it's really easy if you just understand what coefficient is and if you just run the function. Get it right and move on. We're on SAT Practice Test 8, Math Section 1, Question 22. What's the level of difficulty here? Stupid hard. Almost always the last question in Section 1 is stupid hard. You've got this function. It says the function g is defined by g of x equals f of x plus 5. For what value of x does g of x reach its minimum? So let's just write down what we're looking for. One word, minimum. And then what you're doing is you're going to take this function and you're going to follow these directions, which says add. You can do x plus 5. It means that every time you see an x, you're going to add 5 to it. So let's just start by rewriting this function here. 4 times how many x's here? 2 of them. So it's x plus 5 times x plus 5. Every x, I got to add 5 to it. Plus 64, there's another x plus 5, plus 262. Okay, we're going to take these terms one at a time. So we're going to deal with this completely before we move on. So this is 4 times, I'm going to FOIL this, x plus 5 times x plus 5, x squared plus 10x plus 25. Not done. Now I've got to do 4 times x squared, 4x squared, plus 4 times 10x, 40x, plus 4 times 25, 100. And now I'm done with that. So now I'm going to deal with this guy. Plus 64x, that's easy enough, plus 64 times 5. Definitely calculator math. 320. And then I just still got this 262 hanging out over here. And now I can combine terms. Here's an x squared term. Are there any others? No. Little trick here. Once you're done with that term, cross it out. Next thing is the x terms. 40x and 64x. Use your calculator. 40 plus 64. That's 104x. I'm going to get rid of those. And then now I just got 100 plus 320 plus 262. This part doesn't matter, but we don't necessarily know that at this point. Okay. All of this reduces to this thing right here. You're looking for a minimum. A quadratic minimum, you just have to remember this. It's negative b over 2a. Why? Because math people say so. A quadratic function looks like ax squared plus bx plus c. So what is your a term? A is 4. What is your B term? B is 104. C term doesn't matter because it's not in the quadratic minimum thing. So it's negative B, negative 104 over 2 times A, 2 times 4, which is 8. You're so close. Use your calculator. And you get negative 13. And that's the answer to this hard question. It's A. You get it right. And now you get to move on to section 2. We're on SAT Practice Test 8, Math Section 2, Question 9. What's the level of difficulty here? This problem is hard, or I'm calling it hard because it's going to be hard for a lot of people. And it's like so easy that it's hard. A submersible device is used for ocean research. The function g of x equals negative 1 over 55 times x plus 19 times x minus 35. It gives the depth below the surface of the ocean in meters of the submersible device x minutes after collecting a sample. X is bigger than 0. How many minutes after collecting the sample did it take for the submersible device to reach the surface of the ocean? So I'm going to rewrite this function. You should too. The key to getting this problem right is to read the question, read the frickin' question, and understand exactly what the function is. ETS tells you right here. It's the depth below the surface of the ocean. So this function right here is what? It's the depth below the surface of the ocean. X minutes after collecting a sample. How many minutes after collecting the sample did it take for the submersible to reach the surface of the ocean? So what do we want this function to be? It says depth below the ocean. We want to get to the surface of the ocean. So how much under the ocean do we want to be if we're at the surface of the ocean? We want it to be 0. Right, the only thing you can manipulate here are the x's. This negative 1 over 55 is not going to change. The 19, the 35, nothing's going to change. Also, and this is important, x has to be bigger than 0. So how can you get this thing to be 0? The only way to do it is to make this 35. You can't make this negative 19 because x has to be bigger than 0. The only way to do it is to make it 35 minus 35. That's going to get you to a 0 here. And then it doesn't matter what anything else is. All of it's going to be 0. And so the answer is 35. That's it. You read the freaking question, you apply some common sense, you get it right, and you move on. We're on SAT Practice Test 8, Math Section 2. Welcome to Question 10. Level of difficulty is, it's hard. It's really just hard because it's a sucky amount of work. A cube has an edge of 68. A solid sphere with a radius of 34 is inside the cube, such that the sphere touches the center of each face of the cube. To the nearest cubic inch, that's just a license to round, what is the volume of the space in the cube not taken up by the sphere? Question's a little complex. Let's write down exactly what we want. We want the space inside the cube that's not the sphere. So obviously you're going to need a cube. You're going to need a sphere inside. You don't need to know the volume of a cube. You don't need to know the volume of a sphere. You just need to know that you can go to the SAT formulas box and plug and chug. So I'm going to write down a cube. I'm going to label the sides. What are the sides? The length, width, and height are all 68. So the volume is just 68 cubed, or 68 times 68 times 68. Obviously, calculator math. It's 314,432. All right, so the volume of a sphere, start by writing it down, the formula. And then there's only one piece of information you need here, it's the radius. So what's the radius of the sphere. You cannot, well, maybe you can. I can't draw a sphere inside a cube, and it would take all day. But if you just think about this, it touches the sides of the cube. The center is right here. So there's going to be a radius. How long is that thing going to be? It's going to be half of one of the lengths of an edge of the cube. So it's going to be half of 68, which is 34. So it's 4/3 times pi times 34 to the third. 34 to the third, what's that? Calculator math. It's 39,304. So at this point, I know you're just jonesing to use your fancy calculator or the super awesome fancy calculator in the SAT. That's fine. When you do this, remember that you got to keep pi as pi. Do this manipulation, figure out what it is. When you do it, you're going to get 164,636 and then some decimal stuff. But look what it said. Remember, to the nearest cubic inch, so you don't need the decimal stuff. So the volume of the sphere is 164,636. The volume of the cube is 314,432. How are you going to find the space in the cube that's not the sphere? Obviously, you're going to subtract. And when you subtract, you're going to get 149,796. And that's answer choice A. Get it right, and you move on. We're on SAT Practice Test 8, Math Section 2, Question 11. Level of difficulty. It's hard. Got this big ugly equation. What's the sum of the solutions to the given equation? So you're looking for sum. Alright, I'm going to break this equation into parts. So this is a part, and I want to deal with it before I move on to other parts. So x times x is x squared, plus x times 1, which is x, minus 56, that's easy, equals, and then I want to do this part separately. So it's 4x times x minus 7, 4x times x, that's 4x squared, 4x times minus 7 is minus 28x. Alright, you've been doing this since what, 9th grade or so? You know when you got x squared terms, you got to set everything equal to 0. I'm going to put my 0 on the left, because I do not want to deal with negative x squared terms. So I'm going to move this x squared across. It's going to become negative, so it's going to be 4x squared minus x squared, which is 3x squared. Pro tip, I am done with my x squareds, so I'm going to cross them off up here. This is a part that, for whatever reason, people mess up. Be careful. Now I'm dealing with my x's. I'm going to move this x across. It's going to be negative, so it's going to be negative 28x minus x. That's minus 29x. I think it's because it's like 29 is a weird number and people aren't expecting it. Minus 56, move it across, it's going to become plus 56. Alright, guys, you do not need the quadratic equation for this. You can do it. It's dumb. Just figure it out. You got a 3x here. You're foiling this out. You got an x here. You got a minus here and a plus here, so you know these are going to be minuses. And just try something. What's some stuff that you can multiply to get 56? How about 7 and 8? So 3x times x, 3x squared, FOIL it back. 3x times minus 8, that's minus 24. X minus 7x, okay, that's minus 31x, that's not going to work. I did that on purpose because I want you to see that you can just try something else. Try this. 3x times x, 3x squared, minus 21x, minus 8x, that's minus 29x, that's what you wanted, plus 56. Okay, so those are the answers. So I'm going to do it up here. 3x minus 8 could be 0. X minus 7 could be 0. This one's easy enough. X equals 7. This one, you got to do some math. 3x equals 8. Divide by 3. and you get 8/3. So the sum is going to be 7, do it here, plus 8/3. And from here, use your calculator, turn this into a decimal, whatever you want to do. I'm going to go back to second grade. I want to show you something cool. This is called the bow tie method of adding or subtracting fractions. And the way to do it is you don't have to deal with denominators. You just multiply like that. You get 21. You multiply like that. You get 8. You're adding, so you're going to add 21 plus 8. You're going to get 29. And then you always multiply the bottoms. 29/3. And that's the answer. This problem's a lot of work, but you can get it, you get it right, and you move on. We're on SAT Practice Test 8, Math Section 2, Question 12. Level of difficulty is hard. Got an equation for which of the following tables are all the values of x and their corresponding values of y solutions to the given equality. Guys, we saw this exact same question in Section 1 of this very SAT. Evil Testing Service loves this question. You want to know how to be able to do it, and the way to do it is to plug in the answer choices. All you got to do is go down, do the x's and y's, and see which set works every time for the equation. So I'm going to start by writing down A. I'll write the equation. I want to keep a chart of my x's and y's because I don't want to get them confused. So the first time I do it, y is 20. Is that less than 6 times x, 6 times 3, 18 plus 2? Is 20 less than 20? It's not. So A is gone. I'm going to write A, B, C, D. I'm going to cross out A. So I go to B. All right. Keep a chart. 3 and 16. This time, y is 16. Is that less than 3 times 6, which is 18, plus 2, 20. 16 less than 20? It is. Check. Keep going. Next one is what? 5 and 36. All right, so what's our y? 36 is less than 5 times 6, 30 plus 2, 32. 36 less than 32? Nope, it's gone. Don't need to do anything else with B. Go to C. Keep a chart. First set of numbers is 3 and 16. Does that look familiar? You just did it. Check. Move on to the next one. 5 and 28. Y is 28. Is that less than 6 times 5, which is 30, plus 2, 32? Is that true? We're golden. So we move to the last one. 7 and 40. This time y is 40, so 40. Is that less than 6 times 7, 42, plus 2, 44? Is 40 less than 44? It is. So everything worked with C. I don't need to plug in with D because I didn't make anything up. I get it right, and I move on. We're on SAT Practice Test 8, Math Section 2, Question 13. Level of difficulty, supposed to be hard. What is the diameter of the circle in the xy plane with the equation, this equation? All right, what are we looking for? We're looking for diameter. I guess ETS is counting on you to have never seen the circle formula before. If you haven't, it looks like this. All this stuff doesn't matter in this question. R squared, what do you think R is in a circle formula? It's radius. So R squared is 16. R squared is 16. So what's R? It's 4. So what's the radius? It's 4. Do you know what diameter is? It's twice the radius. So it's 2 times 4, which is 8. And guys, that is it. That's the answer to this allegedly hard question. Get it right and move on. We're on SAT Practice Test 8, Math Section 2. Welcome to Question 14. Level of difficulty is hard. For a lot of people, it's going to be stupid hard because it's a quadratic equation problem and they just don't really know about it. If you know the quadratic equation and how to use it, this problem is pretty easy. So you got this equation. In the equation, c is a constant. C is a constant just means ETS knows what this is, but they're hiding it from you. You can't plug in. The equation has exactly one solution. What's the value of c? So write down what you want. And then you just got to know, or put in your calculator, the quadratic equation. It looks like this. So we're going to start by rewriting the equation that Evil Testing Service gives us. And then, is this equation quadratic? Definitely is. Look. What's A? A is negative 9. What's B? B is 30. What's C? Oh, we don't know. A quadratic equation has exactly one solution when b squared minus 4ac equals 0. Let's say that again. One solution is when b squared minus 4ac equals 0. You've got to commit this to memory or put it in your calculator or otherwise know it. If you know this, it's easy. What's b squared? Don't be afraid to put that in your calculator. It's 900. This part's going to trip people up just because negatives trip people up. It's negative 4 times negative 9 times c equals 0. So 900 is this plus or minus? It's plus 36c equals 0. So now it's just algebra. Couldn't be easier. 36c equals negative 900. Going to divide both sides by 36. Obviously, calculator math, negative 25. Evil Testing Service is not evil enough to also put positive 25 in these answers. C is the answer. You get it right. You got to know these things. You move on. We're on SAT Practice Test 8, Math Section 2, Question 15. What's the level of difficulty here? Guys, this question is stupid hard. And I was kind of surprised the first time I did it that it was located at number 15. Because this should be, in my mind, like number 21 or 22. But here we are. In triangle XYZ, angle Y is a right angle. The measure of angle Z is 33 degrees. And the length of YZ is 26. If the area of triangle XYZ can be represented by the expression k tangent 33 degrees, where k is a constant, what's the value of k? So after all that mess, we're just looking for k. As usual, ETS describes a figure to you, doesn't show it to you, so what do you have to do? You gotta draw it. It's a right triangle. Angle Y needs to go here. It doesn't matter where X and Z go. Z's degrees is 33 degrees. The length of YZ is 26. The area of this triangle is K, this is kind of a thing you need to know if you've never taken trigonometry, times tangent 33 degrees. Alright, all this is a puzzle that you got to put together. The two pieces of the puzzle are the area of a triangle. That's half of base times height, as you know. And the other part is SOHCAHTOA. SOHCAHTOA is all you need to solve trig problems on the SAT. Sine, cosine, tangent. What do we got? We got tangent. Tangent is opposite over adjacent. What that means is it's the opposite side over the adjacent side. In this problem, the area of the triangle can be expressed as, that's an equal sign, k times tangent 33. So what do we know here? Well, we know the base, right? It's 26. I'm going to put all my numbers over 1 since I have fractions and non-fractions. It's a habit I have. Recommend it for you, but you don't need to do it. What's the height? That's the height. But I don't know what it is. So I'm going to make it h. Okay, k is a constant. That means we're never going to find it out until we solve the problem. But what is tangent 33 degrees? It's opposite over adjacent. So it's the opposite side over, that's the opposite side. This is the adjacent side, the side next to it that's not the hypotenuse, over 26. All right, guys, I'm going to do this over here. What is the opposite side? This is the opposite side. What else is the opposite side? It's also the height. So guys, I'm just going to put things together here. 1 times 26 times h, which is height, is 26h over 2. That's 13h equals, we said the opposite side is the height, so it's just k times h over 26. And again, I'm going to put this over 1. What is going to happen to these h's in this equation right here? There's an h on the left and there's an h on the right. They're going to go away. So all I got is just 13 over 1 equals k over 26. I got a fraction, an equal sign, and a fraction, so I'm going to cross multiply. I'm running out of room, I apologize. It's k equals 13 times 26. You're going to do that on your calculator, and you're going to get 338. And that's the answer to this brutal problem. You get it right, and you move on. We're on SAT Practice Test 8, Math Section 2, Question 16. Level of difficulty is hard. A slew of people is going to miss this problem because they're going to do the algebra, they're going to get the algebra wrong, but they're going to think they got it right. So I'm going to show you how to do the algebra, sure I will. But before I do that, I'm going to show you a much easier way to do this problem. The regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? So write down what you want. All right, everybody's going to start strong in this problem. It's going to be like, okay, man, price is $11.70. And then you can get to the sale price with one step or two steps. I'm going to go one step. I'm just going to take 0.2 times 1170. I'm going to get $2.34. Now from here, everybody's going to want to set up an equation. But you can figure this out. You know that the sale price, $2.34, is 30% greater than the store's cost. So $2.34 is 30% greater than what? Let's just try something out. I mean, let's just try $2, right? So if it's $2, 30% of $2, what is that? That's 0.6. So you'd add 60 cents to $2 and you'd get $2.60. You were looking for $2.34. That's not right, so you need to go lower. Well, let's try $1.80. Right? You're going to add 30% to it. That's 1.8 times 0.3, which is 54. And then you're going to add 180 and 0.54. And look at that. That's 234. That's what you wanted. So the right answer, you can put it in as 1.8. All right. You don't want a ninja plugin. You want to do the algebra because you insist on it. Fine. Here's how you do the algebra. What's the store's cost? That's the X, and that's why it's so important to write it down. So it's the store's cost, X, plus what? 30% of the store's cost. When we add that up, what are we supposed to get? We're supposed to get the sale price. $2.34. Now, I made it look easy, but no one, like very few people set this up right. Getting out of this, I'm going to multiply by 100 because I don't like fractions. 100x plus 30x over 100 divided by 100, so 30x. Don't forget, over here you got to multiply by 100. I would definitely do that in my calculator, even though it seems really easy to eyeball it. And then you get 130x equals 234. You divide, and at last, it's going to be 234 divided by 130. And that's 1.8. This algebra, again, is where it's going to get you. If you just plug in, you're going to get it right. But here's how to do the algebra. Whatever you do, take your time, get it right, and move on. We're on SAT Practice Test 8, Math Section 2, Question 17. Level of difficulty is hard. Before we start on this problem, I've got to go over some terms. We've got to go over congruent and similar. In geometry, congruent has a very specific meaning. It means exactly the same. So with the shape, all the sides are the same, all the angles are the same, everything you can think of is the same. Similar means the angles are the same. So that means the shape's going to have to be the same, but the sides could be different. So let's just look at two triangles. And you're going to have to trust me on this. These are equilateral triangles. So what are the degrees inside? They're all 60 degrees because equilateral means the same. All right, equilateral triangle, 60, 60, 60. What are the sides of this triangle? Let's say they're 4. Okay, does that mean that this equilateral triangle, do the sides have to be 4 as well? No, they can be anything. Let's make them 12. All right, two equilateral triangles, same angles, different sides. Are these triangles similar? Yes, they have the same angles, they have the same shape. Are they congruent? No, because they are not exactly the same. All right, that's the geometry lesson for today. Let's do this problem. In triangles ABC and DEF, angles B and E each have measure 27 degrees. Angles C and F each have measure 41 degrees. Which additional piece of information is sufficient to determine whether triangle ABC is congruent to triangle DEF? So I want to kind of write down what I want. Really helps to understand the question by writing it down. So just additional information congruent. All right, where are these triangles? These aren't the triangles, and they're not here. So you're going to have to draw two triangles. Don't try to draw them to scale because you don't really know what they look like. Man, that's a brutal triangle. Try and do better on this one. I'm going to label the points. I'm going to go ahead and assume that they're in the same places, although that assumption is not necessary. So B and E have 27 degrees. They're in the same spot. Okay, that's good. And C and F are 41 degrees. All right, you definitely want to write ABCD because you're definitely going to have to cross off here. We are not going to go through a geometric proof. We're just going to eliminate answers that can't be right. Do you know anything else about these triangles? For example, you know there's 180 degrees in both of them, right? You know there's 27 here, 41 here. Could you figure out how many degrees are here just with the information that we have? And of course you could. You're going to take 180 and then you're going to take 27 away, then you're going to take 41 away. And when you do that, you're going to get 112 degrees. All right. What do you think? These triangles congruent? Are they exactly the same? The angles are exactly the same, but what about the sides? We don't know about the sides. Let's go down to the answer choices and see what we can cross off easily. Do we need, as an additional piece of information, the measure of angle A? It's kind of a trick question. We already have that information. We don't need it. We already have it. It's not going to help us, but we already have it. Okay, let's look at D. No additional information is necessary. We need something, right? Because we don't know anything about the sides. So just if you kind of know anything about what congruent means, anything about any geometry, you ought to be able to get this to B and C. Now let's look at B. The length of AB. So if I know the length of AB, I'm going to make it up. I'm going to call it 8. It's my favorite number. So if I know that AB is 8, what do I know in terms of the other two sides of this triangle, and what do I know about the sides of this triangle? The fact is I don't know anything, because this is 4, we said this is 12, but it could be anything, right? So that's not going to be helpful to me. So process of elimination, it's got to be C. There's a geometric proof here that says that if you know one side, both triangles, then you can figure out all the other sides, you can figure out if they're congruent. We're not going to go through that. The important part is A was for sure gone, D is for sure gone. If you plug in something here and think about it, you know that B is gone. It's got to be C. Get it right and move on. We're on SAT Practice Test 8, Math Section 2, Question 18. Level of difficulty here is hard. Most people are going to take one look at this monstrosity and they're going to think stupid hard. They're definitely going to be right. There's going to be 4 stupid hard questions in every Section 2 of every SAT, and this is one of them. You got 2 equations. In the given system of equations, r is a constant. If the system has no solution, what's the value of r? So write down r and circle it. Ultimately, this problem is just simultaneous equations. How do I know it's simultaneous equations? Because I got 2 equations. All you got to do with simultaneous equations is stack them and then add them or subtract them. But in order to stack them, you have to have the x's on top of the x's and the y's on top of the y's. So let's make sure we can do that. Write down the first equation. And then in SAT land, and I think in any math, you need to have your letters on one side of the equal sign. So let's make that happen. 48x minus 72y, we're going to move the 30y across the equal sign. It's going to become negative. Don't be ashamed to use your calculator. It's negative 102y equals 24. And now let's do the same thing with the second equation. This time, I want to move the negative 16x across the equal sign, so it's going to be positive, and I want to move it all the way over here so it's directly under the 48x. The ry is fine, it's plus ry, and then the 1/6 is also fine. And now, I've got 2 equations that are stacked in a way that I can add them or subtract them. But I got a problem. I can't add these or subtract these to do anything useful, because when I add or subtract, I want something to go away. So what I need to do is I need to multiply or divide one of these equations by something that'll get me to a place where I can add or subtract. I'm going to multiply this equation, every term in it, by 3. So when I do that, what's 3 times 16x? 48x. So now I'm going to be able to get rid of my 48x's. Got to multiply every term, so it's plus 3ry, and then 1/6 times 3 is just a half. All right, I'm done with this stuff. I'm going to rewrite the equation over here. You don't really need to rewrite it. You could just cross this off and keep going. But let's make it easy to look at for ourselves. Okay, last wrinkle. This system has no solution. What the heck does no solution mean? No solution means all the variables drop out. And I've double underlined variables. X is a variable. Y is a variable. What's R? First of all, it's what we're looking for. Second of all, it's a constant. All a constant is a number that ETS is hiding from you. So that is not going to drop out, and we don't want it to drop out. If I subtract here, I'm going to get 48x minus 48x, which is 0. That gets one of my variables to drop out. My other variable is y. How can I get y to drop out? In order to get y to drop out, I need to make 3r equal to negative 102. So 3r equals negative 102. That's just simple algebra. 3r divided by 3, negative 102 divided by 3. I know you'll use your calculator there. R is negative 34. R is negative 34. That's the answer. Before you go, I want you to make sure you understand this. 3ry is 3 times negative 34y, which is negative 102y. Negative 102y minus is going to be negative 102y plus 102y, which is going to make my y's go away. And then I've got no y's, and I've got no equation. And if I got no equation, I got no solution. This problem is very hard, but you can get it right and move on. We're on SAT Practice Test 8, Math Section 2, Question 19. Level of difficulty here. It's pretty stupid hard. When I first did this problem, I was really concerned because I was like, I know how to get this problem really easily, but it's only because I've done like 8 gazillion SAT problems. And I was worried that I wasn't going to be able to explain it. But then I read the Evil Testing Service explanation for the problem on the SAT website, and I didn't feel so bad, because my explanation is way better than that one. Which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? So b is a constant, just means that ETS knows what it is, they're hiding it from you, and it's a positive integer. So you've got these things, these are called polynomials. You've been doing this for a long, long time. You know that you're going to like unfoil it, and it's going to look like this. You also should know that you're going to have 3x here and x here. And you should know that you're going to have plus signs, because these are all plus signs. You're going to need a 7, because look, these are all multiples of 7. And where is that 7 going to have to go? It's going to have to go right here. B could be a multiple of 7, but 2 isn't, so it's going to have to go right here. So this thing right here is x plus 2b, the thing in parentheses right here. So all you got to do is figure out what's going to go right here to make one of these things happen. Let's just say b is 1. It's got to be a positive integer constant. If b is 1, then what's 2b? It's 2. I'm just going to make a chart here. If b is 2, then 2b is 4. If b is 3, then 2b is 6. b is 4, 2b is 8. b is 5, 2b is 10. b is 6, 2b is 12. b is 7, 2b is 14. And we could go on forever, but I'm out of room. And we'd run out of time. Just try one of these out. Try a b. Let's start with a nice easy one, like b equals 2. So if b equals 2, then 2b is 4. So it's x plus 4. When you FOIL this thing, it's going to be 3x squared plus 12x plus 7x, that's plus 19x, plus 28. Okay, did we get a bullseye? Unfortunately, we did not. So that one's not going to work. So you say to me, you say, Eric, this could go on forever. There's no way this is going to work. And I guess you could be really unlucky. But guys, remember what I said? There's got to be a 7 in here. Go with the 7. Try making b 7 so that 2b is 14. And when you do that, you're going to get 3x plus 7 times x plus 2b, which is 14. 3x squared plus 3x times 14. Might do it on your calculator. That's 42x plus 7x. That's 49x plus 7 times 14. You definitely want to do that on your calculator. You get 98. Okay, do we hit a bingo here? Well, hey man, we do get a 49x. That's good. What is our b? b is 7. 14 times 7, and that's 98. So the key to the whole problem is 7s. This makes everything work. We have an answer that fits it. It's D, and we get it right, and we move on. We're on SAT Practice Test 8, Math Section 2, Question 20. Level of difficulty here is hard. This Section 2 is kind of brutal, but this problem, even though it's located at number 20, is actually not very brutal. The perimeter of an equilateral triangle is 624. The height of this triangle is k root 3. K is a constant. What's the value of k? So let's write down what we're looking for. All right, where is this triangle? It's not here, as usual, so you got to draw it. And then what do you know about this equilateral triangle? Well, all the angles are the same. All the sides are the same. So can you figure out the sides? Sure you can. 624 divided by 3. Calculator math, that's 208. So the sides are 208. The height of this triangle is k root 3. Is the height one of these sides? No. The height is a straight up and down distance from the bottom that makes a 90-degree angle. And that's important. How many degrees are right here and right here? 60. Now, if you cut a 60-degree angle in half, you're going to get 30 and 30. And also, if this is 90 and this is 60, this triangle on the right has 180 degrees in it, right? So this must be 30. So you've got two special right triangles. You've got two 30, 60, 90 right triangles. You do not have to memorize anything about special right triangles. They're in the formulas box. I guess it'd be a lot cooler if you did memorize it, but they're there for you. This is a 30, 60, 90 right triangle, which is special. What makes it special? Well, what makes it special is that it's half of an equilateral triangle. 30, 60, 90, 30, 60, 90. The sides of a special right triangle, that's a 30, 60, 90, are x, 2x, and x root 3. And again, you don't have to memorize this. It's right here. So can you then just transport x, 2x, x root 3 over to here? Sure you can. What's x? It's going to be half of 208, so it's 104. 2x is 208. What's x root 3? It's 104 root 3. All right, the height of the triangle is k root 3. That's the height. So k root 3 equals what? 104 root 3. What's k? 104. This problem is very easy. Well, it's not very easy, but it's a lot easier than a lot of the hard problems around it. You can get it done pretty quickly and move on. We're on SAT Practice Test 8, Math Section 2, Question 21. What's the level of difficulty here? Most people are going to take one look at it, think about where it is on the test. They're going to think, this looks stupid hard. And guess what? They're right. You got two sets of data. Forgive me, I have to read this long problem. Two data sets of 23 integers. Each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. The second interval represents the frequency of integers greater than or equal to 20, but less than 30, and so on. What's the smallest possible difference between the mean of dataset A and the mean of dataset B? So let's just start by writing down what we want. We're going to try and find the means of dataset A and B, or we're going to try and find the smallest possible difference. Let me just ask you a common sense question. Which of these sets do you think is bigger? This one has some numbers from 20 to 30, 30 to 40, 40 to 50, and 50 to 60, and has 9 from 50 to 60. This one has some lower numbers, and then its highest numbers is 9 of them from 40 to 50. So what's bigger here? A is bigger. B is smaller. That's really the key to figuring out this problem. You do have to write some stuff down. A lot of kids don't want to write stuff down, but you gotta. But then you can calculate the stuff you write down. if you know that A is bigger and B is smaller, and you want to get the means, the smallest possible difference between the means, so you want to get the means really close together, you want to get the mean of A as small as you can, and you want to get the mean of B as big as you can. What are the numbers here? It's 20 to 29. Greater than or equal to 10, but less than 20. Greater than or equal to 20, but less than 30, and they're integers. How many integers from 20 to 29? 3. All right, what about 30 to 39? 4. What about 40 to 49? 7. What about 50 to 59? 9. And you can check and see if you've got this right, because there's supposed to be 23 integers, okay? 16, 20, that's 23 integers, so I'm golden. From 10 to 19, remember? Greater than or equal to 10, but less than 20, and they're integers. 10 to 19, how many of them? 3. From 20 to 29, how many? 4. From 30 to 39, how many? 7. And from 40 to 49, 9. All right, this does not take as long as it just took us. You just got to roll up your sleeves and figure it out. And once again, 16, 20, 23. So if I want to make A as small as possible, what do I want the numbers from 20 to 29 to be? What's the smallest I can make them? 20. And there's 3 of them, right? So that's 60. From 30 to 39, I want to make it as small as possible. 30. And there's 4 of them, so that's 120. From 40 to 49, small as possible. 40. And there's 7 of them, so that's 280. 50 to 59, 50. And there's 9 of them, so what's that? 450. And now you get to use your calculator. So you're going to add up all these numbers on our calculator. You get 910. You're looking for the mean, so what do? You divide by the number of things. When you divide 910 by 23 on your calculator, you're going to get this nasty looking fraction. 39.5652, blah, blah, blah. Looks like it goes on forever. Okay, we're going to do the same thing over here. Remember, this one was smaller. We want to get the means close together, so we want to make this as big as possible. So from 10 to 19, what's the biggest you can make the numbers? 19. How many of them? 3. Might want to do that on your calculator. That's 57. These are definitely calculator math. We want to make this one as big as possible, so 29 times 4. Put that in your calculator. It's 116. 39 is the biggest that you can make this one, times 7. Definitely going to do that in your calculator. 273. And then you want to make this one as big as possible. There's 9 of them. 49 times 9. 441. Add up all these numbers, and you're going to get 887. And then you're looking to do the mean, so what do? Divide by the number of numbers, so that's 23. And you get this big old ugly fraction, 38.5652, goes on forever. Okay, so what's the smallest possible difference? Well, what did we just find? We found a difference of 1. And guys, that's it. That's the answer. It's a brutal problem. It takes a while, but it doesn't take as long as it just took me to explain it. Get it right, it's B, and you move on. We're on SAT Practice Test 8, Math Section 2, Question 22. Supposed to be the hardest question on the entire test. Guys, this problem is a gift. It's hard, but it's not that hard. Got a poll. The table shows the results of the poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll, if 6,424 people voted in the election, by how many votes would Angel Cruz be expected to win? So what are we looking for? Just write something down that makes sense to you. Guys, this problem is a ratio. And ratios are really easy if you use a ratio box. Ratio box has 3 rows. There's the ratio, there's the multiplier, which is the key to the whole thing, and then there's the real world. So what are we taking the ratio of? Cruz and Smith, and then a ratio box always has a total. I'm going to put in some lines here to make it easier for us to look at. I don't know that you need them. Alright, what do we know? Cruz ratio is 483. The ratio is the pole. Smith ratio is 320. And they tell us the total, but that's just Cruz and Smith added up, 803. In order for a ratio box to work, you've got to know something about the real world, and you always will. What do we know about the real world? It's the total. 6,424 is the total number of votes. So the multiplier is the same across the ratio. How can you multiply and get from 803 to 624? You divide to find out. It's 8. So for Cruz, you're going to multiply 483 times 8. That's 3864. And for Smith, you're going to multiply 320 times 8. That's 2560. So you got all the information you need by how many votes is Cruz going to win. It's obviously going to be subtracting these two numbers. I know you're going to use your calculator. You really don't need to here. It's 1304. That's the answer. It's B. And hey man, good job. You're done with SAT Practice Test 8.